All right, here we go. All right, this is the last lesson of the unit. And Unit 2 is one of our biggest units, so congratulations. We're almost through it. See, there's 9 lessons. There's so many lessons in Unit 2. This is geometric sequences. Same stuff we did on Monday. Remember Monday we had arithmetic and geometry, where arithmetic was adding. Geometry is finding the sequence by multiplying to get to the next term. So just to remind you, if I look here and I have my set B, and a set is just a series of terms. And if we go from, let's go 1, 7, 49, 343. Look at that and tell your neighbor, how do you go from one to the other? Before, like yesterday, we were adding. What's happening here between the terms? What's happening? Okay, Flo, what is it? Times 7. Times 7. So from 1 to 7, times 7. 7 to 49, times 7. 49 to 343, times 7. Okay, you see it? So this is a geometric sequence. I'm just reminding you of the context for today. Now, if we are, we already dealt with this, remember? This was the desired, you might add this to your notes. The desired is equal to, if I'm looking for the 10th term, n minus 1 is the 9th term. So it's the desired is equal to the prior term times our common ratio. Okay, R is our common ratio. That is the value, that's how much we multiply to get to the next term. So you can see here, if I want to know what this term is here, 49, I would look to the term prior, 7, and I'd multiply by 7, which is our common ratio to get to the next term. That's how we're doing it. We already know this. This is stuff we've done in the couple of units or lessons we've done with this. This one's new. This one's a little bit new. So with this one, first we already looked at this, common ratio. You find the common ratio by taking the current, or the one you want. So I would take the current, say 1.5, and I would divide it by the prior, 3. Remember we did this a few times before? Okay, so you just got to remember the common ratio set up like that. So the ratio between these is to multiply by 0.5. Multiply it by 0.5. I'll make that a times. There we go. So we look 3 times 0.5. 3 times a half is half of 3, 1.5, and so on. Okay. So common ratio, recursive, we already did. Now we're going to look at explicit. So explicit, just like yesterday, explicit is the way that we can also create a new function, a new equation from the information we have so we can find any term. But let's look at this first. What are our terms? I'll call this A sub what? A.
So A sub 1.
Good.
A sub 2.
Good.
A sub 3. A sub 4.
Everyone good with that? That's just the number, that's in our, the number in order for the term. And it looks like we're looking for A sub 5, 6, 7. We're looking for A sub 7. That's really bad. A5, A6. We're just looking for this one. We're finding A sub 7. So let's look at this. Let's find the common ratio. I want you to work that out right here. Actually, looks like you already did. What's happening to these numbers? Tell your neighbor, what's happening to our numbers as we go? Is it getting bigger, smaller? What are you multiplying to get to the next term?
Smaller.
What do you think? Brian, what do you think?
It's decreasing by half.
Good, good. And when you decrease by half, you're either dividing something by 2, right? Or you're multiplying by half. So since we're doing multiplication here, you can express multiplication as division in that way, but we're going to keep it this way. We're multiplying by 0.05. Dang it. So it's going to go all the way across to get to here. So we got our common ratio. Ratio is 0.5. All right. Use explicit formula. So now we're going to use an explicit formula. We're going to look for, what term are we looking for? A
sub 7.
A sub 7. So watch. A sub 7 is equal to, what was A? Excuse me, A sub 1.
3.
3. How do you know? You can look, you already labeled it. It's first term. A sub 1 is first term. So we have first term times, what's our ratio? This is how I want you to do it actually. I'm going to put it in as a parenthesis here, because we're going to match it to exponential functions, or just multiplying to get to the next term. Remember, it's where the steps are different and bigger as you go up.
Is it
So,
0.5 raised to 7?
0.05 raised to the watch. 7 minus 1 though. In is what we're looking for. In is what we're looking for. So when you get over here, this, you gotta watch out.
Why is it that?
7 minus 1.
Why never curse when it's like you don't have to use the minus?
It's true, because here the n minus 1, this is an exponent. This is just it's speaking about the sub number, the number of the term.
So it's not the prior part.
Correct. We aren't going to put the prior term, but we are going to put the exponent, the exponent that matches the prior term. I didn't say that quite right. But let's do a couple like these. 7 minus 1 is what?
6.
So look, this we can do. Think of PEMDAS. I want you to write PEMDAS right here. That's why, because the reason why is we need to assess that real quick. What are the two functions that are going on right here? What's going on?
Multiplication and
multiplication and an exponent. Which are we going to do first? Multiplication or exponent? Exponent, then multiply. So you'll need a calculator for this. Go and get out your calculator. I have a couple here. Who wants one? I'll pass this over to you. Let's round it to the thousandth place, just like we have here, to the thousand.
Okay, 0.016.
Is there a point zero?
Oh, we didn't multiply the thing yet, so it's the
answer. That's 0.016.
The answer, like the actual value is 0.015625. So it's 1.0.
That?
Yeah.
Okay. So PEMDAS doesn't equal that. That was just there. So the way we do that, we have to remember that we use PEMDAS. We're going to do the exponent first, so 0.5 raised to the sixth, and then just put times 3, and we got our seventh term here. So this was here. All right, I want you to do, since we have this, I want another practice here. So I want you to find.
Do we need to multiply the?
I thought that's what you did.
No, I said I raised 0.5 to 6, and that's what it was.
Oh.
And then when multiplied is 0.0468.
Go 0.47. That's what I wanted. I wanted the final answer. So we got it now?
Yeah.
Everyone find that? You can do it on your calculator? Do you need help on the calculator? Yeah. Maybe check with your neighbor, double check. You know, don't know how to do it. I think with the exponent key, if you want to do an exponent that's more than 2, it's this. X to the y. X to the y. Or it might be, let's see, what else was it? The chevron symbol. That's how you would get up to the exponent. Yeah, you have a hard one to work with, Danny. Is there another one I can do? No. I used to have a pink calculator. I don't know what they... Is that the one that's one? I used to have 2 pink calculators. Oh. Okay. All right, let's see. Let's do it. 0.5. This raised to the 6. Yeah, that's backwards of what I have up here. Okay, I want you to find, are we going to worry about this? I want you to find the 91st term.
Oh.
Wait, that's horrible. Not for this problem. Not for this problem.
It's going to be so many decimals.
I know, it's going to be horrible. Let's go ahead and find a sub 10. Yeah, let's find a sub 10. Same process. You already know your ratio.
0.0029.
You already got it. It's too fast. All right, we're going to take the first term, our ratio, and then it's 10 minus 1. So what should I put here as the exponent?
Oh.
Didn't do that, huh?
No.
10 minus 1. Don't forget, the function is the ratio raised to the exponent of 10 minus 1.
Okay, the answer
Wait. Let everyone do it a little bit. To the 9th. Okay, make sure you can do that on the calculator. You got it on the calculator. That's a lot of popcorn, huh?
Yeah.
Did you say so?
Yeah, I'm not gonna eat till like later on.
Okay.
So I have to like be fully part of the rest.
Oh man. Yeah, don't eat right before that.
So I'm not eating one. So
Yeah, throw up. Alright, Atsiri, what'd you get for this?
0.0058.
Okay. And we can leave it a little further out because
we're gonna need to round it.
you know what, I would leave it anytime I have 00 and I want to round to the 1000th place, I'm gonna add like a 10,000th place there. Because so many of the digits of 0, it's like it's like significant figures when you get to different science levels. So kind of like, well, what's necessary? I want to be more true, and this would be more true than 006. Okay. Thumbs up, sideways, down so far. Can we do this? You can do it. Okay, let's do this one here. This one is, you're writing explicit formula. So remember, explicit formulas, we don't plug in something here. This is going to become our f of x. I'm going to let you try to do this one. We did problems like this yesterday. If you don't remember, it's no biggie. We'll go over it. Let's see.
Did I say a sub 5 equals that?
Yeah, that's a sub 5, and we know the ratio, common ratio is 5. You're going to write an explicit formula to find any term. Any term. Looks like we have to find what the first term is first. We don't know that. So, how are we going to set this up? What do you think?
Are we doing it now?
Yeah, let's do it right now.
We used the recursive formula.
Oh, you know what? This one is, yeah, this one actually I'm going to show you. We'll do another one like it. Because it's a little tricky. Because we need to find what a sub 1 is, right?
Yeah, should we use the recursive?
Yeah, but we are going to use explicit again. We're going to use explicit. That's what this is.
Oh.
So watch. A sub 5, right?
Yeah.
I'm going to put a 1 in it. A sub 5 is 1792. Okay? And this is a sub 5. We're gonna do it with what we have. R, okay, so then we'll have a sub 1, that's our original, the initial. We have
5.
R, and then since we were looking for the fifth term, it was 5 minus 1. You see? I had the fifth term, so I put it in as a sub n is a sub 5, fifth term. My initial term, I don't know, I'm going to find it. My ratio, common ratio is 5. Here it's n minus 1, since it was the fifth term, I had information on it's 5 minus 1. So this essentially is what?
4.
Do 5 to the 4th power. Let's see, 5 times 5, 25. 25 times 5?
625.
125 times 5, 625. You're always in the future, Simon.
The future is amongst us.
Perfect. If I want to know a sub 1, what do I need to do right now?
Go back in time.
Now, you were in the future, now you're in the past?
Yeah.
Yes. We're going to divide by?
17.
We're going to divide by 625 because I want to isolate. Now, really focus on this one, Simon. I want to know the initial. So I divide by 625 because I want to isolate that. Look what happens. Now we have it isolated.
Oh, so the answer is on the left is going to be the a sub 1.
Correct. See how it's just by itself. Now we know what it is. And this looks like it's probably,
Let me see.
I don't know.
2.8.
2.8? Just 2.8?
6.
All right, good.
Do we round that?
Yeah, give me 3 digits there, 3 decimal places.
7.
7? 2. Yeah, we'll keep it there. 7.
Oh, that's not like the 2 stuff.
That's a sub 1. Okay? We did all that work to find a sub 1. Now we're going to go into this.
And find any problem.
We're going to find an actual equation for this. So let's look, watch. A sub n. Wait, why is this 4? Let me double check if I wrote this one down wrong. It won't matter. All right. I think this might have been a ratio of 4, but it doesn't matter. We can do it on 5. It doesn't matter. Okay. Now watch. A sub n is equal to, what was my, that's, okay, that's fine. What was my a sub 1?
2.867
Okay.
times
What was my common ratio? 5.
and then can we do like 100 or like 7?
We're going to actually leave this just like that. This is my formula.
Oh no, that's it. Or we have an extra.
Yeah, that's it. Now watch. If I want to know what a sub 1,000 is,
You can plug into the end.
yeah, a sub 1,000. See, we set this up so that we have the ability. What's 1,000 minus 1?
999.
You see, I'd be able to find the 1,000th term because I created a formula for it to plug in.
So it's the
So
same,
it's harder.
same as yesterday, really.
It's the same. Yesterday was arithmetic. This is geometry. It's multiplication. And look, we see this before. This is our exponential function. Watch. This is the initial, right? Right. This was our growth factor,
Yeah, ratio.
the rate, right? And this is our exponent. So we have an exponential function we're creating. Okay.
Wait,
This part's kind of tricky, but I only gave you like I think 1 or 2 problems like that. What do you think? Thumbs up, sideways down. What can we do? That was tricky. You went down and up. I remember that. All right, guys. And then what was the funny thing we want to say at the end of the lesson?
My life is funny.
No homework.
Yeah.
Like,
Yeah.
well, I'm gonna give you enough time here. Like we have another 20 minutes, so we can do everything in class. I'm hoping. Yeah. All right. How about hopefully no homework on 3?
Okay, hopefully no.
All right. 1, 2, 3.
Hopefully no.
Like Danny was out, but he was just like, no homework. Not hopefully. Okay.